Hi, Shashank. Good afternoon. Welcome to this mock interview video for data modeling and system design part for any data engineer interview. So this is like the third or the second round of the data engineering interviews that are conducted. So before starting, let me just introduce myself. I am Surbhi and I have 7+ years of experience in data engineering world. I started my career from a service-based company and then recently moved to a product-based company. I have been in data engineering itself from the very beginning and have knowledge about various clouds like AWS and Azure. And in terms of the programming languages, I have experience with SQL and Python. Also, since I'm in data engineering, I'm well versed with Spark, which is like the backbone of the data that we deal with. And data modeling and system design questions will start appearing if you are giving interviews for like 5+ years of experience or 6+ years of experience, because at that time you apply for senior roles and that is required. Yep, over to you.
Okay, so I'm Shashank Chakravarti and I'm currently working as Senior Analytics Engineer at Modern Data Company. So here I'm working with one of the client, which is the largest supplier of wines and spirits in United States of America. So helping them to enhance their operations towards supply chain as well as the marketing campaigns using the various data engineering techniques such as migration and creating data models, as well as some of the materialized views that actually helps to empower their Tableau. So also with that, the client has achieved around 50 to 60% of ROI with the work that I have done. And post that, I was working at RTP Analytica as the data engineer. So where I have worked on creating end-to-end data pipelines for one of the programmatic firms, which is UK based, which completely aimed at improving the bidding algorithms at the demand side platforms, and um, aim to optimize their campaigns as well. So here I've worked on multiple APIs and pulled the data through it and put into the GCP, so that it could be used to analyze their campaigns as well as optimizing the bidding algorithms. So there, the client was able to achieve 30% of ROI based on it. And my skills include mostly uh, with Python, SQL, PySpark, and some of the scheduling tools such as Airflow. And along with it, I also have experience on the cloud such as AWS and GCP and Azure. Um, so, so that is all about me.
Yeah, wow. Great to hear. Like, it seems that you have knowledge both about the business and the technical part. The way you were explaining the project from a business perspective, also, it's really, great to know that, yes, it's not technology that you know about, but you also know about the business problem that you're trying to solve. So, would you like to explain one of the recent projects that you did in your company? Which benefited the client, and like who was the client, what was the problem statement that the client came to you with, and what was the solution that you prepared, the architecture of the solution, the tech stack that you were using in that uh, solution, and if there were any optimizations that you applied. So yeah, with that perspective, can you explain one of the recent projects that you did?
Yes. Okay. So recently I have worked on creating some of the data models. One of the major problem that customer was facing is firstly related to the inventory management,
Okay.
where the major problem that the customer faced um, was mainly related to, for example, on their website, if you are ordering some of the products. So for each product, there will be, for every order there will be some invoice generated. So the invoice will have will have the number of orders, and those order will contain some of the products. So as a result, the client was not actually aware of of giving the real time insights on the product going out of stocks.
Okay.
So because of that, what actually was happening, that there were many of the products booked, but then it actually went to the back orders. As a result, some of the orders were getting completed and some were not, resulting in the customer churn and also affecting the customer relationship management. And second issue was related to the campaigns. So where what it was observed from our end is, there were some campaigns in some states of US that were running very successfully, but had very low conversion rate. So
Okay.
what we did is, we solved this problem by analyzing, by coming to know to the conclusion that this campaign, that for example the campaign for one particular brand has been running in the Arizona, but but the sales for that brand is actually higher in Florida. So
Okay.
that is what we observed, and based on the analysis and through those materialized views, those problem was solved. And secondly, the problem was also related to the inventory management. So how it was solved is, we compared the 2 years data. That
Mhm.
is, for example, if you want the inventory of the current month, so that of the current year. So what we were doing is, we were comparing it those of previous those of previous years 90 days sales.
Okay.
So based on that, we were taking out the daily consumption ratio, and based on that, we were comparing it with the cases on hand. And through that, within every 2 hours, we used to give the insights on the website, uh, that if the product is out of stock or not. So this also helped to solve this problem of product going out of stock. So what we did is, like, we prepared a few of the data pipelines, and since as the data was from various sources, so we unified the data into a one single source. Mainly that was from the GCP, and some of was from Salesforce, which completely contained the offline data. So merging both, it actually gave merging both on joining both the data, we created a white table that actually helped to analyze the orders at both the end, offline and online both.
So you talked about GCP, you talked about the pipelines, and so I just wanted to understand how is the entire flow of this. Data is coming, and then you're finally reporting it out to the website team, telling them what product is out of stock, etc. So what is the entire flow of data, that architecture that you have maintained for this flow of data from the very beginning to the very end?
Okay, so there are three various sources. Uh, one is uh, One is from GCP, and another is from Salesforce, and some of them contains the SAP data. So all those data were brought into the S3, and using those S3 buckets, there were two loads initially. One was the historical load, and another was the incremental load, which was completely based on day to daily basis. So once you have scheduled it on the incremental basis, so those the so once you have all those data loaded, so those data for 2 years were put into the Redshift, and using that the data using that, we perform some of the transformations using PySpark, materialized those views in the Redshift only by aggregating the KPIs, by aggregating it based on the levels that they want. Uh, so that was also divided into product and customers view,
Okay.
and from there, using PySpark, then those data was put into the, again we created those materialized views, which was linked with Tableau.
Okay. Okay. So How did this entire flow run every 2 hours? Like, was it Airflow that you were using for, scheduling the jobs, or how was it?
So we were mostly using Airflow for scheduling the jobs,
Okay.
and for monitoring and management we had Kubernetes, which was linked with Prometheus, which used to give the real time insights and alerts as well related to the jobs. So that actually helped to maintain the monitoring that actually helped to maintain the monitoring of the jobs, as well as the alerting system was maintained uh, using the Prometheus API, which where we were able to identify the uh, job failures and successful runs of jobs.
Okay. 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 And okay, now coming to the data modeling part, like what were the main facts and dimensions? Like, did you create any facts and dimensions in this project that you just explained?
Yes, so there were yes, so there were a few tables of facts and dimensions that we have created. So one was the order, which completely acted as the fact table, because
Okay.
because what we have observed that it was completely because it was giving the real time insights. Um, so that was the which acted as the fact, and then there we had tables related to the product, customer, and we had product, customer, and then we had further which was linked with the order line items, which contains order table, and then order line items table, which contains various details about the orders. So that is how it was designed. And then there was another dimension table, which is known as warehouse, which consisted all the data related to the products, like how much product is there in hand, or how much product is how much item is actually present, and cases on hand, and contain all the data related to it.
So you said that your data was coming like real time. Like, for example, if I'm a user and I have placed an order, then you as a data team member would come to know that an order has been placed. So, like, was it like a transactional DB, or was it like, I'm trying to understand the OLTP and the OLAP part of it. Like, was this table wherein the data was coming on regular basis? Like, I place an order and you have it in your on your screen. So was it like a OLTP system, and then the data moved from this OLTP system to the OLAP system, or it was just one system? That's it.
No, it was OLTP, because OLTP, and then it was moved to OLAP system.
Okay.
Because yes, so it had all the real time insights along with the historical data, and then from there we moved it to the OLAP. That's how we did.
Okay. Okay. Understood. Understood. So that movement of data from your OLTP system to the OLAP system happened after every half an hour, 1 hour, or 2 hours. So how is it like? Because there's
It was,
frequency.
yes, okay. So it was completely based on the business and our identifications. What we had observed upon analyzing is that in every 2 hours the inventory was going out of stock for some of the products. So based on that, we scheduled the inventory part for every 2 hour basis, and for the order analysis, like what we have observed, like within every 10 minutes the orders were getting placed. So that was scheduled on every 10 minutes for orders, which gave real time insights on the placement of orders.
Okay. Okay, then I think with respect to the project, okay, I was able to understand it, and yeah, it was a good discussion that we had on the project. Okay, now let's move to the system design question that we have for you. So let
Okay.
me first the question is already visible on the screen, but let me just go through it with you so that I'm able to
Yes.
explain what is required out of you. So first is the introduction as to what is the business background about the design problem that we're going to solve. So we have to design a platform for the advisors. They want to see some KPIs. These KPIs that they want to see, they want to analyze the data which is
Yes.
coming. this is the financial data and it is coming from various clients, and each client can give the data in different formats, and the source of the data will also be different because it's coming from various clients. Now, the main purpose is to design a lake house, and then this lake house will be used to determine the KPIs that the client needs. Now, since it's the finance data, you see these 4 files that we'll be talking about right now. One is the accounts. Accounts will just hold a static information that, okay, these are the total number of accounts that are present with a particular bank. Transactions. This is going to be a huge table which will store, the frequent updates. It's like a banking transaction that I go to a bank, I do some transactions, then I come back
Yes.
again, I go and do some transactions and all that. Then we have advisors. Advisors is also like, you can think of them as the financial advisors which are there with the bank. So there'll be a limited set of advisors. So yeah, this date table will also have less volume of data and won't have much data. Now, assets. Assets is again, for example, there's a consumer or there's account person. So whatever assets he or she is having, so that would be present in the assets table. So it can be of moderate volume, not as much as transactions, but not as low as account or advisor table. Okay. So yeah, these are the files which are coming, and the end goal is making a lake house. And you can use any cloud of your choice. We'll be doing it we'll be trying to solve this problem on the cloud
Yes.
platform. And yep. Given the introduction, these are the design questions that we want to address while creating the design. One is, so maybe we can take these questions one by one. If you have already understood what the problem statement is, then maybe we can go
Yes.
ahead with these questions. Okay. So here the question is that how would you design the directory hierarchy in our data lakehouse to efficiently manage and isolate data from multiple clients, considering the diversity of data sources and formats? And also you can just state the cloud that you're going to use in this entire design.
Okay. So consider. Okay. So let us consider that there are some of the transactions that are actually there are various sources that we can take. One transactions we can take is that we can take from AWS S3, and we can take sources as AWS S3, and here some of the data related to the customer is being stored in ADLS Gen 2.
Okay.
And yes, so using that, um, let us consider in this. So we will mostly bring data from S3 to Azure. um,
Okay.
so what we will do is uh, okay, and here this will be. So what we will do here is, like, once we have brought the data from AWS through Azure. So what we will do is, once we have data, so there are several different clients. Here we have multiple clients. So here we will have the different structure, which will be here we can have different structure. For example, client 1, client 2, client 3, client 4. And
Okay.
then in that we can upon that we can bring the data into it, and then based on it we can partition the data on the basis of banks and date, which will store all those details about which will have all those details. So that is our first part. So this will help us to handle and know uh, this will help us to handle and know, like, where, like, for which customer we are bringing the data. So that could be managed by creating a file of clients and customer. So where this file will actually contain all the details of what all clients are there, and based on it you can run the pipeline.
Okay.
So here, what we will use, um, so like once we have this directory, so like once we have the all these, okay, what is the other part? Can you please scroll down?
Yeah, sure. But I have to ask some questions over here. So
Yes,
you said the folder structure is going to be first the bank name and then the dates. Would we also be having a folder for the files? For example, we are having 4 files. We talked about 4 files. So do you want to
yes,
create the folders for the files as well?
yes, yes. There will be folder for those files as well. That will be transactions. Um, that will be transactions, and um,
Yeah, they were
so
assets
those
and
could
advisors.
be on the basis of, yes, transactions, accounts, transactions, advisors, and assets. So there will be three
Uh-huh.
folders inside it. So there will be so yes, so there are total 4 tables, and only transactions will be partitioned because this will be because this will act as the fact table, because every time the real time insights are being updated into that table. However, assets, advisors, and accounts will be the static tables, because not much amount of data is being updated. But however, there may be few of the cases that may happen, like for example, if the if you consider the advisors, so there may be few of the advisors that whose number may change or their email may change. So in order to maintain that, in order to track those, we will have to go with the method known as slowly changing dimensions, that will help us to track the record for each and every account, for each and every advisors, accounts or assets, and every as well as the transaction. So here, so only surrogate key, we will generate a surrogate key over here, that will also help us to track all those changes based on the based on the updates.
Okay. Okay. So I think we talked about surrogate key, but I think that surrogate key thing you're not going to implement in just the starting layer, right? First, you would uh
Yes.
you would be having the steps, right? First would be, for example, the layering structure you would be following to bring in the data.
Yes. So the layering structure that we will follow is the Medallion architecture. Which will be into the raw, which will be divided as once we bring the raw data, so it will go into bronze, silver, and gold layers. So once it is into the gold layer, so we can say that the data is good to go for the analytical process. Um, So further, this data can be stored into the data warehouse, and then it could be connected with some of the tools such as Tableau, or Power BI, something like Power BI, like that.
Yeah, yeah. After the goal, you're saying that we can move it to some data warehouse
Yes,
and then to the reporting tool.
yes. So that data warehouse can be inside DB, or it can be Azure SQL as well. There we can move.
Okay, right, right. Okay. So I just wanted to understand. So this thing that you told is absolutely correct. That we will be moving the data in the form of Medallion architecture, which is a great approach. And then the goal layer is for analytical purposes. The data warehouse, the example could be inside DB, which is also good. But then we talked about this folder structure. So this folder structure, are we going to maintain in all the layers? Like in raw also will be making partitions, in bronze also, silver also, like, is it going to be like that, or how is it going to be?
Yes, inside, because we will have to store. Yes, what we can do is, like mostly. we see that only gold can be the gold thing that we have. We can store all there can be two cases where we can have historical data being stored as the bronze silver here, and for gold what we can do is we can only take 2 years of data, which can be mostly be needed for comparison of transactions, the current versus previous years. So that could be so that we can process it into the gold layer, and then we can put it um, into the uh, into the database. So it completely, what we can say is, it completely depends upon the business case. So for that also we will have to create the various structure. We will have to create the various folder by naming as bronze underscore the transactions, or bronze underscore silver, or bronze underscore gold. That will actually help to know like what kind of data we will have to use, and which data has to be moved to the data warehouse.
Okay. So what I was able to understand with what you just said was that in the gold layer, we can just have 2 years of data because that is something that business would have requested, and they would have
Yes.
actively wanted to analyze the data for 2 years. And then in staging, which is just the previous layer, we can maintain 10 years of data as well.
Yes, we can maintain that historical data as well.
Right.
So
Mhm.
so what will it does is, like, if in any case there is a need to analyze historical data, that also we can move it, that is into cool and hot tier. So in cool tier we can store historical, and for hot tier we can store 2 years of data.
Yeah, okay. Great, great, great. Yeah, yeah, yeah. So, okay. Yeah, this partitioning structure is also correct. Okay. Okay, one question. Is it possible that it is also possible that every source will send you will send you the files in different formats. Like from one bank, we can get a CSV file for advisors, but from other bank, maybe you are getting a JSON file for the
Yes.
advisors. Do you think your current the current thing that you've told me would be able to handle that case as well, where you are receiving you know, one file format and another file format from other vendors? So is it something that you have planned or you have taken into consideration?
Yes. So as we see about the file structure, so yes, obviously the data will be coming in the various file formats, CSV and JSON, which are totally columnar, which are totally row-based format. And as the JSON contains keys and values, so that will actually make data very heavy, and as a result, the data volume will be very high. So in order to reduce, so while processing those data, what we can do is we can store the data in, like, once we have the raw data, and once we have processed it, so we can store it so we are storing it in various layers. So in those layers we can store data in the form of columnar storage, which is known as the Parquet, which follows the snappy technique, mainly uh, to reduce the size of the data. It compresses the data size, because what we see the difference between them is, like, the column and row type. So column type is the most efficient way, because that will help us to get the insights, and are good for reading, and are actually good for reading as well. However, while writing, this will take some time, but when you read it and when you fetch it, the fetching time and the latency may get reduced.
Okay.
So what we can do is, because it also follows the partition techniques. So those partitions will also help us, will also help the data analysts to filter the data based on the dates and accounts. So that will be a huge boost to the analyzing of data and reduce the time, as well as will also help to uh, save resources that are being used to query behind the client, and is also good for cost optimization and cost saving.
Okay. Okay, understood. Yeah. So the partitioning technique we need to follow, columnar storage we need to follow so that we can optimize
Yes.
the space that we are using. Yeah. Okay. Okay. Given the high volume of transactions, so you are saying that I will partition my data, and partitioning we already discussed that we'll do on the bank name, and then we can also do based on the year,
Date.
month, and date.
Yes.
Great, 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 great. That is good. That is good. And for the various file formats, you have already told that in the bronze layer, you will write such a code so that all the file formats will be converted to the Parquet file format. So even if you would be getting a CSV or a JSON or an XML, you will be converting everything into Parquet format when you
Okay.
move to the bronze layer. And then from bronze layer onwards, it will be Parquet only to the next layers, right?
Yes. To the next level, it will be Parquet.
Understood. Understood. Okay. Nice. Coming to the ETL pipeline design now. Okay. So here, let's try to see some questions. Like, what are the key considerations you would prioritize in designing an ETL pipeline for the solution, ensuring scalability, adaptability to different client data formats and structures? And the next question is that how would you approach the challenge of transforming diverse data formats into a structured format that supports efficient analysis and KPI generation? So, yeah.
Okay. Yes, so coming to the consideration of designing ETL pipeline. So as we have discussed earlier, like we will considering the Azure cloud. So here we will be using Azure data factory to bring data from various sources. So here we will parameterize. So here we will create a copy data activity, and we will uh, parameterize the file names as well as the sources from where we are bringing. Uh, so what we'll have is like so once we have created so once we have created all those link services for various cloud platforms, we will also create an Excel file, or we can also create a simple database which contains the values of all the details about the clients and their files and the location. So based on which this will help us to make the pipeline dynamic while bringing the data. So we will load this data, and once the data is loaded, then from there we will perform some of the transformations, because there may be few of the transformations which may be very high level of transformations, like where we may have different levels of JSON, which may be up to level 10 or more. So in order to transform it, we will use the data bricks to transform those. And so using that, once we transform it, we will store all those data in the Parquet format in the Delta Lake. So once it is saved in the Delta Lake in the Parquet format. So that is what approach we will use to process the data and bring the data. So as we can see in the UI, so which will be where we will create two activities. So one is copy data and another is Databricks activity. So once the copy data is successful, so then all those transformations will happen, and like that we can schedule a trigger in on the basis of on the basis of timestamp, or on the basis of business requirement, like at what time the business needs the data, which can be real time, or which can be in a day. So based on that, some of those uh, we can schedule some of those pipelines as well.
Okay. I think you said the control tables and the dimension tables that we are going to create is going to help us in the scalability and adaptability. So in case a new data set is coming in future, that will be easily handled if we already have that control table structured in place, which the ADF will be using, right?
Yes.
Right. So control and metadata tables are going to be really helpful in our case.
To control the scalability and adaptability. Yes.
Okay, understood. Yeah. And then how would you approach the challenge of transforming diverse data sets into a structured format that supports efficient analysis and KPI generation? So what would you
Okay,
like?
so yes, so transforming all these, we will mostly, as I said, like we will be using Databricks. So here, it completely depends on what kind of it completely depends on what kind of data you have. If it is a heavily nested JSON, so then you will have to use the recursion loop in order to take out all the insights out of it. Then there may be various processes, like where we can use various function in Spark, such as explode, which actually provides a view, which can help to break the JSON and into the most simpler forms. Then further, about the KPIs, that the generation that what we talk about is will be based on the business, like what KPIs the business will provide. Based on that, we can perform transformations using the Databricks, that will actually help us to take out the insights, if it's on yearly basis or if it's on daily basis, like how many transactions are happening. There can be a much more to to get the insights out of it, that may actually help the bank to track day to day transactions and optimize their business.
Okay. So I think in the very first step, I want to ask, so for example, if you're having a nested JSON in the very first layer, and while bringing it to bronze only, we are saying that we'll be converting it into a Parquet file. So, you have a nested JSON, you have a CSV, you have a TXT. How are you going to tell your ADF pipeline that, that if a JSON is coming, then do this. If something like this is coming, then do this. So are you going to have a kind of flag in your control table, which will let the copy activity know what kind of thing it has to go and, like how would the copy activity know that, okay, now I'm having a JSON and I need to use this Databricks notebook to convert it into Parquet, because other see,
Yes.
if it is a normal CSV file, you can just use the copy activity source and sync and do it. Right. But if you have a nested JSON, you would have to use a Databricks notebook or some other, XYZ thing to get it converted. So your control table, I think, would be helping you to
Yes. So that will be,
uh,
yes, that control table will help us to deal with various file formats.
okay, great. Okay. Okay. Now, the last question for the system design is that, uh, considering the financial sector's dynamic nature, how would you ensure that the data lake house and the ETL processes remain flexible to accommodate new types of data entities and evolving relationships over time?
Okay, so as we have discussed earlier, there will be two things that we can consider. Is number one is storing the data in the form of delta lakes. That actually gives us the capability. That actually gives us the capability for schema evaluation as well as the time travel. That can also help us to handle the various snapshots and version control. And then and then second thing comes up is of slowly changing dimensions, because there may be few of the instances where various data, where many changes can happen in the data, like for example, the customer the tra- the accounts that we have or the advisor that we have, their number, their phone number or their email may get changed. So we will use surrogate key in order to track all those details. And also, so once we have the surrogate key, so based on that, you can track each and every record of that particular customer. That is very essential to for the joins and analyze what changes are happening. And um, yes, and further we can also put some of the monitoring and alerting system in the ADF in our ADF pipeline that will help us to actually get the details like whenever what evolution has happened or what changes are being happening, that we can use monitoring, alerting, and monitoring system in the ADF. That will be very essential to help us to track the details of all the process.
Okay. 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 I think, yep. And I think whatever solution that we have talked will help us achieve this adaptability. Like not just the points mentioned here, but the overall architecture that we discussed will also help us to do the same things. Uh, so,
Yes.
moving to some random questions I would ask now, not
Yes.
related to the project or related to system design, but related to data modeling. So, do you know what is normalization like in layman terms?
Okay. So normalization is the process of where we are, uh, where we are reducing the repetition of the data. So this is mainly in our term what we call is we reduce the redundancy. For example,
Okay.
consider a list. For example, here on we have one of the table, and in the C point that I can observe, which is the employee table. So here we see the dependencies of each column. So, like for example, employee name is completely dependent on the department and is completely based on department. So means these are repeating.
Mm-hmm.
So these are repeating again and again. Like HR is repeating two times, and New
Right.
York is repeating two times. So that we can reduce it. So that will actually help us to give a more readability of particular tables that we can um, so that we can reduce it.
Okay. Okay.
And will also help us in yes and also help and will also help us in optimizing reading of those tables. So um,
Like doing the writes on the table. Like I can update the table, right?
yes, right.
Updates and inserts. Yeah.
Yes, we can update upserts and inserts. You can perform very easily
Yeah.
on those
Okay.
tables.
Yeah. So basically, you just mentioned that this table is having redundant data. Like we saw that the HR New York combination is repeating twice.
Yes,
So this is not a normalized table. I will have to make some changes to make it normalized, right?
yes,
Okay. Can you tell me what changes would you
yes.
make it
So
normalized?
yes, we can mainly divide it into two tables. Number one is employee table, and number two is the department table. So where the employee table will have employee ID, employee name, and department,
Mm-hmm.
and there will be second table which will be known as the department, which will have department and department location. So here department can be so in the department table this department column can actually act as the primary key to join both the tables.
Okay. To convert the
So
word
here so
into
yeah.
normalized table. Yeah. Yeah. You were saying
Yes.
something?
No, just only this much into two parts.
Okay. Understood. Understood.
We can name it as PK. We can put it in the bracket as PK department
Yeah. It's PK
as yeah,
for
which will denote primary key.
Yeah.
primary key.
PK for
Yes, department
department
table
table, and FK for your employee table, right?
for employee table. Yes.
Okay, taken. The point taken. So, one simple question over here, like we have multiple normal forms, right? We have one NF, then we have two NF, three NF, and so on. Okay. As
Yes.
we move up the ladder, like, are we going towards like which is better? Like one NF is better or four NF is better? If I just talk about it, or three NF is better.
So what I can say is, like it completely depends on the use case,
Okay.
like what use case you have. So when it comes to the transactional DB, or when it comes to the relational DB, or when it comes to the uh, analyzing those tables. What we can say is, like for transactional DB, definitely, the 4 NF will be good, or your higher normal form are good. But mostly when it comes to the analyzing those tables, when we will analyze it, so it will involve a lot of complex joins, that may use a lot of resources behind the cloud, and may affect the query performance. Only the one normal one NF will actually work, uh, which will which will reduce all those problems related to the resource utilizations, as well as the complex joins, that all we can avoid, and it will help us to analyze the data very easily.
Understood, understood. Yeah, that is completely a good answer that you weighed the situation both the ways. So we can have a transactional DB situation, or we can have an analysis DB situation, and for both of
Yes.
them, it depends. It depends. For transactional DB, if we go to the higher forms, it is good, but if we do the same with the analysis DB, it is going to consume a lot of resources. Yes, because like we can
Yes.
see in this example also, if I need to find out the location of every employee, I'll have to do a join. If for example, if I've
Yes.
normalized, then I'll have to denormalize it again. Okay.
Denormalize it again.
Okay.
So one of the benefits what we can observe here is, like, whenever we are doing any insert, or any uh, insert or any update operations, that could be done very easily when the table is normalized. But when it's denormalized, so then it's definitely it becomes a complex process.
Yeah. Okay. 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 Coming on to this only, the transactional DB and the reporting DB that we just talked about, what do you think? The snowflake schema kind of a design that we have in data modeling, is it for which DB it is suited? Like, is it more suited for a transactional DB, or is it more suited for a reporting DB?
Yes, so Snowflake schema, it is mostly, as we see the structure of Snowflake schema, which involves which involves fact tables, and then there may be another dimension tables connected to the one dimension tables. So that actually makes a very complex. For for reporting DB. But for transactional DB, yes, that Snowflake schema is very well suited, because, as we have discussed before, like it gives you, it gives you a good way to, for the upsert, for upsert operations, as well as, but when it comes on upon reading the data, so then again it involves a very complex joins, which may use a lot of resources uh, behind the scenes in the cloud.
Okay, understood, understood. Yeah, I think in continuation, we have this another question also, where let's talk about the OBT approach, which is the one big table approach. So have you used it, or, if you can just elaborate on the advantages and the disadvantages of the same?
Yes. For yes, so we have used this OBT approach in our current project also. So what I have done here is, like combining all the where I have combined the data of products, orders, and customers. that actually helped in RFM segmentation for customers. Uh, that actually helped me to go with the RFM segmentation that helped to analyze the churn rates as well as help to maintain the customer relationship management. So this actually makes us very easy to analyze the data. But when it comes to um, where you don't have to perform a lot of complex joins, you have everything created in a one go. So this is this is the very easy way, but then there comes some of the disadvantages as well. So the disadvantages will actually have where once you are updating the records, so then it is very complex process. And another thing is um,
Yeah.
like there will be a lot of data redundancy.
Yes, there will be a lot of. But do you
So
think in the current
that is not
world,
good.
data redundancy is a problem? Because right now the storage is really cheap, right? And so even if the data is redundant, you don't have, you know, this implication of cost over there because the storage is cheap. And then you also talked about columnar data storage, right? Which is far more
Yes.
optimized in storing. So uh, I think this data redundancy is not an issue nowadays because we have very cheap storage available and optimizations also available in form of the optimized data formats or big data formats that we have.
Yes.
So I
Yeah.
think the main thing is the updates are complex. Like it is
Updates are
not suited.
complex.
It is not suited anyways for a transactional kind of a DB.
Yes.
Okay, Shashank. So I think that was it from my side.